All right, so I'm going to talk about a couple different forms of the equation of a line. So these are all going to be linear functions because they are functions of a line. First form is the slope-intercept form, and that looks like this. Y equals, so notice that y is on its own for slope-intercept form. M, and M here is going to be your slope. We'll talk about that. That's this guy, slope. X, which I'll do in red. That's just your X and your Y right there for your coordinates that make up that line. And then plus this little guy in the end, B. And we'll talk later about why this is B. It seems kind of like a strange letter for this, because B is your intercept. In fact, it is not just any intercept, it is the y-intercept. And the y-intercept is where your line hits the y-axis on your graph. So maybe here's our coordinate plane. And wherever our line crosses the y-axis, that's this guy right here, the y-axis, is going to be where that b value is. So if we crossed right here, that's at 2 on the y-axis. So our y-intercept would be 2, b would be 2 for our equation. If we had down here, it'd be -3. So we'd have -3 for b. And if we were right here in the middle, that's at 0. So our y-intercept would actually be 0, which would lead to an equation that doesn't appear to have a y-intercept, although we know that +0 is really there. So a lot of different options for our y-intercept and our y-axis. M, is our slope, and that's going to be the angle of our line. So if you can imagine, there's a lot of different lines that I can put on this graph right here, all kinds of different lines. And there's two things that really define them. One is where they hit the y-axis. Some lines don't hit the y-axis at all, like this one. And the other thing is what angle after they hit the y-axis are they going away at? So after I hit the y-axis, I'm going away at this angle here for this line. Whereas after I hit the y-axis in the same spot on this line, I'm hitting it in the same spot, I'm going at a steeper angle here. So that's going to be our slope, the steepness of our line. So here's a couple examples with y equals mx plus b. And my first one is going to be this. Y equals a slope of 2/3 x plus 1. So let's take a look at this. What does all this mean? Well, the +1 we already know, right? That's going to be our y-intercept. So if I was to graph that, we'd get something like this. Here's my graph. My y-intercept would be here because this is 1 on the y-axis. That's where our line is going to cross the y-axis. We don't know what angle it's going off of there. It could be any kind of crazy angle, you know, something really steep or something completely flat like this, a horizontal line. But it's going to cross right there, and we know that. This is our slope, and we talked about that earlier. Our slope, okay, is right there. The way we talk about slope is this. We use the M for its symbol because the French named it, and their version of slope in French starts with an M, I believe. I don't know what it is, but it is M. It's a good thing they don't use S because S's look like 5s. And slope is going to be, you probably heard this before, the rise over the run. And the idea here is that slope is how much our line, whatever it is going up and is going over. So the rise is how much it's going up, and the run is how much it's going over. And this ratio right here between how much it's going up and how much it's going over, the rise and the run, is going to be our slope, and it's going to give this an angle to it. So if the rise is really, really high, then maybe we have a really, really steep angle. And if the rise is really, really low, then maybe we have something that's almost completely flat. So the closer this ratio is to 1 over 1, which is this ratio right here, every time we go over 1, we go up 1. The closer it's going to be to this line right here, and the closer it is to 0, which is this ratio right here, the closer it's going to be to a flat line, so like 0 over 1, going up 0 over 1. So up 0 over 1, up 0 over 1, up 0 over 1. So the bigger the number, the steeper it is, and the closer that number is to 0, the more likely it is to be a flat line. So how do we calculate slope? This is the slope formula right here. Rise is just how much you went up. So it's going to be the difference between your y values. So between any two coordinates on your line, any two dots that you have on your line, there's going to be two y values. If you subtract them, you'll find the distance between them. So you'll find out how much they've gone up vertically. So if I've got a dot here and I've got a dot here, well, vertically they're separated by 2. That's 2 right there. So their distance would be 2. And that makes sense because this guy would be something comma 3, right, for its height. And this is 1 for its height. And the difference is 2. And that's how we find it. That's how far they are apart. Remember, subtraction is distance. The run, on the other hand, is going to be the same idea, but with the x's, because the x's are what goes left and right. And that's how we are defining run. Run is our left and right distance. Rise is our up and down. So it makes sense that the rise is the y's, because y's go up and down. And the run is the left and right, the x's. So if I had another point, this guy, and I don't know, maybe this one right here, the rise between those points would be 3, because this guy's up at 4 and this guy's at 1. The difference between them is 3. And the run would be also 3, because this guy's over at 4 and this guy's at, or I'm sorry, this guy's over at 3 and this guy's at 0. So 3 is where he's at horizontally, and 0 is where he is at horizontally. So the distance horizontally is 3 between them. So you can kind of eyeball it without having to plug in numbers, but you could do that as well. So our slope is 2/3 x, and our y-intercept is 1. So what we're going to do is after we found our y-intercept, we're going to take that slope and apply the up 2 over 3 to find another point. And once we have 2 points, we can draw our line. So I plotted my y-intercept. We always do this first. And then I apply the slope. Well, the slope says up 2, so I'm going to go up 2 from there. That's 1, 2. So that was up 2. And then I'm going to go over 3. And that's a positive 3, so just like the 2 went up. The 3 was positive, so we're going to go to the right 3. Just showing you how I'm moving there. And that's going to be where our next point is. So I'm going to put a dot there for our next point. I'll do that in, let's see, how about blue? So we have our first point, which is easy to get, 1, the y-intercept. That's where our line hits the y-axis. And then we found another point using slope from there. So from the y-intercept, we went up 2 over 3. And that got us our next point. And now we have enough to make a line. So that's the line, y equals 2/3 x plus 1. Another example. Would be a line like this. So here's the equation of the line. Y equals, let's do a slope of 5 this time, x, and a y-intercept of -2. Oops. So again, our slope is the 5, and the -2, this entire thing right here, is our y-intercept. So if we were to graph this, I'm going to draw a little graph over here, coordinate plane. It says that we're supposed to go down 2 first. We always graph our y-intercept first and find out where our line hits the y-axis. So here's the y-axis. It hits it at -2. So -2 is right here. And then we use our slope to find our next point. Now this slope is not a fraction like the last one. So you might be wondering, what's our rise versus our run? Well, our rise is going to be 5. And our run is actually going to be 1. Because 5 as a fraction is 5 over 1. And we need it as a fraction so we can tell what our rise is, the top number. And our run is the bottom number. Whoops. Rise versus our run. So now we have everything we need to graph this in slope-intercept form. First thing I'm going to do is do -2, which is right there. And then I'm going to go from here up 5. 1, 2, 3, 4, 5. And over 1. And that's going to be where my next point is. I can keep doing this if I want, actually. 1, 2, 3, 4, 5, and over 1, again and again and again. And I'll keep finding points. Same thing if I go the opposite. Instead of going up 5 over 1, if I go back or down 5, 1, 2, 3, 4, 5, and back 1, I'll also find another point that will be on that line. So I'm going to draw that line in now that I have those 2 points, and I'll do that with a straight edge. I'm terrible at connecting points. That wasn't bad. So that line right there is y equals 5x minus 2. And if you notice, between these two lines, the one we drew first and the one we drew second, if you check it out on here, this line is steeper than this line. And that's because its slope, 5 over 1, is bigger than the slope here, 2 over 3. This number is closer to 0, so it's closer to being flat. And this number is closer to being almost a straight line going straight up. It's really, really big, right? 5 is a big slope. So it's a steeper slope than something that's 2/3, which is really close to being 0, right? 2/3 is pretty close to 0. It's actually even less than 1, right? It's a fraction less than 1. So this is a shallow slope. And this one right here is a very steep slope. It's because this number is the biggest. Also notice that the y-intercept here is minus 2. So we start down here for our y-intercept. And this one has a positive 1, so we start up there. So the minus 2 and the plus 1 kind of move it up and down. So this line shifts up and down on the y-axis. And the slope sets the angle. Now last thing, we did mention before this thing with the slope-intercept, or I'm sorry, not slope-intercept, the equation, the formula for slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The reason we say sub is because 2 is underneath y sub 2. That is not y squared. It's y number 2 minus y number 1, right? So the idea behind this is that if you're given 2 points, you can find the slope between those 2 points. And we've done that, right? Here are 2 points. The slope between them is up 2 over 3. Right? 2/3. Oops, scoot down a little bit. The slope is 2/3, up 2 over 3. So given any 2 points, we can find that slope. I can do that by eyeballing it. For instance, if I get a graph and I'm told that this point right here and this point right here are on my line, I can look at those points and find their rise over the run between them and find the slope. So if I go up 4, that's our rise, and over 4, that's our run, our slope, m, is 4 for our rise, and it just so happens that it's also 4 for our run. Now what's interesting about this type of slope is that this is a fraction, 4 over 4, and you know 4 divided by 4 is just 1. So our slope is 4 over 4. It can also be thought of as 1. It can also be thought of as 1 over 1. And that makes sense, because if you were to go up 1 to here, and then over 1 to here, and to keep repeating this process over and over and over again, you would in fact end up at this point right here. So the slope up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1 is the same as up 4 over 4. They are the same slopes because they are equivalent ratios. 4 divided by 4 is the same thing as 1 divided by 1. And so when we connect these with our line, we notice that this slope matches the slope of this line, and so does this slope. They're the exact same thing, just 2 different ways to write it. So if we were to write this equation, we would notice that the y-intercept appears to be right there. This is our y-intercept right here. And that is going to be at 1, 2, 3, 4 as well. 4 is everywhere. So the equation would be y equals our slope is 4 over 4 or 1 over 1. I'm just going to use 1. And remember, 1 times anything is itself. So instead of writing 1x, I'm just going to write x. Now remember that slope there is not 0. There is a 1 over 1 that's hidden there. And then we have our y-intercept, which we said was 4. So there's the equation of that line right there, the blue line that I just drew. I found the slope by eyeballing how much up and over these 2 points are apart. And then I used that to draw my line and then find my y-intercept. Now, what if they don't give you a graph? What if instead they give you just 2 points? And you don't have nice graph paper like I have right now. I'm going to keep that formula right there for us to look at. What if they just give you 2 points and they say, hey, I've got 2 points, -2, 5, and I've got 3, 0. And I want to find the slope between those 2 points. Well, we can do that. Slope formula allows us to. So first off, we need to label our coordinates. Let's call this coordinate number 1. So that's x number 1 out of this coordinate. And that must be y number 1 out of this coordinate. So this is coordinate number 1. Oops, I just lost my pen. Coordinate number 1. And let's call that coordinate number 2. So if that's x1 and y1, then this must be x number 2 and y number 2. And now we do our formula. The important part is to make sure you do the second guy first. So y2 minus y1. Now, it doesn't matter which one's y2 and y1. We kind of just labeled that ourselves. But whatever you choose to be y number 2, make sure you do that one first and then subtract y1 from it. So if you do this guy minus this guy, make sure the next step is to do this guy minus this guy. The order matters here. So number 2 first, number 2 first. Number 2 first here, number 2 first there. So let's write this out. So y2 we said was 0. So let's plug that into our formula. That's 0. And then we're going to subtract y1 from it. Well, y1 is 5. So we have this. Then we're supposed to, on the bottom, subtract x2 minus x1. And I'm plugging stuff into my formula, so I always make sure to wrap in parentheses so I don't make a mistake. x2 is 3. x1 is minus 2. And now we just do some math here. And it's a good thing I wrapped in parentheses because we have two negatives here. And if I didn't wrap in parentheses, I might just write a 2 next to that minus, thinking that, oh yeah, that's a minus 2. I put a 2 next to it. So it's very good to wrap these in parentheses so you see that this is going to become a positive 2. 0 minus 5 is minus 5. I'll write that in green. And that's going to be over 3 minus negative 2. Well, if we already have a negative 2 and we negate it, we're going to flip it and make it a positive 2. So 3 plus 2 is what's happening here. And so that's going to be a 5. And look, we have a slope, negative 5 over 5. Our rise is negative 5, so we're actually going to go down. And 5 on the bottom means 5 to the right. So for every 5 we go down, we're going to go over 5 to the right. Another way to think of this is negative 5 divided by 5. Well, we know negative 5 divided by 5 is just negative 1 divided by 1. Or in other words, negative 1. Either or will work. So we could have a slope of any of these. All of those equal m for this function, this line. So the line between these 2 points has a slope of negative 1 over 1, negative 5 over 5, 1, whatever you want to call it. So if we were to write its equation, it would look something like this. Y equals our slope, which we found out from over here, is negative 1 over 1. I'm just going to write it as minus 1. Oops, that's a minus next to that. Minus 1. Maybe some of you caught that watching me. X. And then the b we don't know. We really don't know the y-intercept at this point. And we'll talk about that later of how to calculate the y-intercept and find that. But in general, the 2 things I wanted to show you in this video are how to use slope formula, which is this guy right here, if they give you 2 points, which they did. And then also be able to use the slope-intercept form, which we know looks like this. Y equals whatever m is, which is our slope, x plus b. So this is slope-intercept form. It makes it really easy to graph a line. All you need is to use the y-intercept here, the b value, to plot your first point, and then use your slope to go up and over to find your next point, and then you can draw your line. That's the usefulness of y-intercept form, and I'll see you in the next video.